Hey, everybody. Heads up. Come on, wake up. Cluster API time. Hi, everyone. We're going to get started here. It's about 1 minute till the official start time. How's everybody doing today? Is everybody having a good conference? Nice. How about that announcement earlier today? I'm officially VMware as of like an hour ago, so that's pretty rad. So yeah, we're going to get started as folks kind of finish coming in. We got quite a bit of time at the end of our presentation for Q&A. A lot of folks have had questions about what we're going to be talking about tonight. So if you have questions, don't be shy and feel free to come up here if you're interested in seeing more and learning more. So yeah, hi, I'm Kris Nova. I work for VMware now, which is exciting.
And my name is Loc. I also work at VMware.
So cool. So it started off as a Heptio VMware combo presentation that just at the last minute turned into VMware combo presentation.
Yeah, when I asked Kris to join up with me to do this, I thought we would be two companies, and then 2 months later.
The same company. OK, so let's get started.
OK.
OK, so everybody take your cell phones out and take a picture of this. This is like the appendix for the presentation. So all references that we make throughout the presentation will be in this. Also, feel free to tweet. I know we look lovely up here. And as we go through the presentation, any references we make you'll be able to find here. And we'll remind you again at the end of the presentation as well. So yeah, I'm a senior developer advocate. My job is to advocate for Kubernetes. And as of today, I'm VMware. And I do a lot of work with the CNCF and just Kubernetes open source in general. I've been maintaining a lot of packages in Kubernetes for about 2 years now. And I met Loc through the SIG cluster lifecycle, which is where the cluster API is. But we'll get more into that later.
And I'm an open source engineer at VMware. Been focused on the container space the last 3 or 4 years. And today we're going to talk about cluster API.
Nice. OK, so speaking of cluster API, go ahead. Who here has used the cluster API before?
Oh. OK.
Who here has not used it but wants to start using it or is excited about it? Nice. OK, so just to tell folks who are in the front row, most people put their hand up for the second one. Most people are interested in learning more. So we're going to start off today, and we're going to learn a little bit about the cluster API today. And we'll talk a little bit more about the history of how we got here. But this is sort of what is the state of the cluster API project today? Yeah,
so this is not going to be a deep dive. There's going to be another session later on this week. Anyway, let's go ahead and get started. So the cluster API today, so what is cluster API? The cluster API is a framework that is designed to handle day 1 and day 2 operation. Day 1 operation meaning deployment and installation. And day 2 is managing, upgrade, scaling. And the cluster API was designed to be a standard for to make the ecosystem less fragmented. And I just want to point out that we're still experimenting. So a lot of the things that we're going to talk about today, it may change. OK, so just letting you guys know.
Awesome. So the cluster API, it's a project that came together that attempts to solve what it looks like and what it feels like to bring up a Kubernetes cluster. A lot of folks, Heptio, now part of VMware, DigitalOcean, AWS, Google Cloud. We've had folks from Azure, contributors from other open source projects like Terraform. A lot of folks who are notable in the community have come together and said, we are tired of this fragmented experience for bringing up a Kubernetes cluster. We all represent clusters in a different way. We all have a different scope for what it means to bring up and manage a Kubernetes cluster. And the whole point of the cluster API is for the community to come together and define what that looks like and the processes and the steps and the scope of bringing up a Kubernetes cluster, but not necessarily the implementation. That's going to be the responsibility of cloud providers like what you see on the screen here. So the project defines the shape of the API structure and not necessarily what that translates to for vSphere or AWS or Google Cloud. OK, so this is another one of mine, I think.
Oh, yeah, that is.
So to make a Kubernetes pun, here's the declared state of the cluster API. I wrote a blog on this, which if you took a picture of the appendix, like I told you to, you can find a link to the blog page. But this project was started in 2017. The origins of the project sort of came up all around the world at the same time. We talked about this in COPS when I was first working in Kubernetes COPS. We talked about this in KubeCon, a project I made to bring up Kubernetes clusters. The folks in the kubeadmin department have been talking about this. We even had folks from companies overseas like Lodsay, and then ultimately sat down with some of my friends at Google, and we sat down and said, okay, we're tired of having different APIs, we're tired of having a fragmented experience. Let's come together and let's actually formalize this and make this a Kubernetes official project. So some of the original goals of the project that we hope to solve, and again, these come from lessons learned from tools like COPS and KubeCon, is we wanted automatic transactions for the cluster management operations. And that's a really fancy way of saying if something breaks, we want to guarantee that it's going to break in a clean way. We don't want to have halfway deployed clusters anymore. We don't want to bring up a virtual machine that isn't configured properly or is missing security authentication. We want to make sure that it either works in its entirety or it fails in its entirety. We have cluster automation, which again, this is just plugging things into the cluster API. If we do things in a declarative way, we're able to build on that and write other tooling that can simply scale and change our clusters from underneath us. Resilient infrastructure. So we see this all over Kubernetes. If you write a controller, you write an operator, something changes accidentally, those operators go back and try to fix it. They're continually working towards this desired state, and we can now get that with infrastructure, which we haven't seen before. We want to improve user experience. This is going to be who here is an operator, sits down at the command line and actually manages a Kubernetes cluster. OK, so you're the people we're talking to. We want this to be as intuitive and as graceful for you as possible, and we just want you to feel like you have everything you need right there at your fingertips. Last but not least, cluster upgrades. Who here enjoys upgrading Kubernetes? OK, so maybe, what do you think, Loc, 10 people? So we want to solve that. We want to start standardizing how an upgrade is going to work. And last but not least, we wanted to create a community. We had a lot of small communities that were all sort of fighting each other, and we hope to bring people together today to work on this. Last but not least, we have one last additional goal, which is cross-infrastructure deployment. This was the original promise of Kubernetes in the first place, to be cloud agnostic. We want to bring that to infrastructure. So that's the cluster API in a nutshell.
OK, cluster API basics. First topic is cluster CTO. So this is a bootstrap CLI that was built by the project, and it was designed to bootstrap cluster API. And right now, every provider implements their own version of cluster API, cluster CTO, because it requires some logic from each provider implementation. Deploying controllers to read CRD objects and deploy CRD objects to, wow, okay. So we have a couple of CRDs objects in Cluster API representing things like cluster, machine set, and machine deployment. Machine set and machine deployment are kind of analogous to replica sets and deployments. And then, like Kris said earlier about the reconciliation, that's how the declarative action occur because of the controller reconciliation loop. And yeah, that's it.
Awesome. So yeah. So how this all kind of fits together to look at the high-level picture here. Here's a basic diagram that has a lot of small squares on it. But basically, there's three main components here that you need to concern yourself with. The first one is the cluster controller. The second one is the provider's cluster actuator. And this last but not least little square over here is very unique specific information that's unique to a provider. In this case, we're using vSphere because we both work for VMware now. So Cluster Cuddle is the command line tool. It's modeled just like kubectl and all the other Kubernetes, CTL, control, whatever tools you want to use. And then basically it goes and it creates a CRD, and then we deploy these controllers, and these controllers reconcile the CRD. It's the same operator model we heard from our keynotes this morning when we learned from etcd. Also, by the way, congrats to etcd for making it to the CNCF today. But the cluster controller is special because for the first time we're actually reconciling infrastructure. So in this example, let's sort of go from left to right. We define a cluster spec. So this represents a Kubernetes cluster. Who can think of an example directive that we might want to define here? API port, perhaps? What port do we want the API server to listen on? What version of Kubernetes do we want to run the control plane? So these are all things that you would go and define here, and most of these are going to map to kubeadmin. Furthermore, we go down a layer into this other thing called the provider spec, and this is going to be the unique implementation for all of the different cloud providers behind the scenes. In this example, we actually are going to be using the vSphere provider, which is similar to how a cloud provider works for the rest of Kubernetes. And last but not least, we have this really wonderful status that we haven't seen yet in Kubernetes management. If you go and you create a cluster with kops or with KubeCon, you kind of just have a cluster. But what's the status of our cluster? How do we query that? How do we build tests against it? How do we gain observability into our cluster? These are all problems that have yet to be solved. Now we finally have a status because we're actually having a controller that goes and runs against the state of the world. So as we drill down into the provider-specific bits, this is the square in the middle, you can notice that we are going to start defining things that are important to vSphere. So these could be things that would define like the size of the virtual machine. Perhaps we could put some network level configuration in here, the size of our disks attached to our virtual machines. And these would translate one-to-one to things that are important to my specific cloud provider. The beauty of this is now it doesn't matter what cloud provider I'm using. I can go and define whatever higher level spec I want, and then that's going to translate into my cloud specific information for me. And last but not least, you can see we have the vSphere spec expanded, and we have username, password servers. So these are all going to be Kubernetes level objects that are bundled up into the provider-specific bits. One of the reasons we chose to have provider-specific bits is because we learned the hard way after trying to do this in kops and trying to do this in KubeCon that actually trying to find an abstraction that works against all providers was never going to happen. So we decided to keep the top-level directives as simple as possible and put as much into cloud-specific provider information as we could.
Okay, moving on. Let's define a couple terms so that when we talk a little bit further, you guys understand. So the first term we want to define is target cluster. So this is the cluster that you actually want to create. Then the next term is bootstrap and management cluster. We're going to talk about the difference between the bootstrap and management cluster later, but this is the cluster that you're going to use to deploy cluster API to then create the target cluster. Okay. Cluster CTL we already talked about, and provider implementation. This is again, every infrastructure provider will have to create their own specific provider implementation.
And these are the official terms that we picked out in the SIG after many SIG calls of arguing what we should use. So I'm going to try to be on my best behavior and use them as correctly as I can. OK, so let's talk about these two usage modes. So these are the two possible types or two possible flavors of creating a Kubernetes cluster with a cluster API that you may or may not see. A lot of the cloud providers are still in an experimentation mode, as Loc mentioned earlier. And one of these is usually going to be the path in which they choose to go down as they look at how they want to start creating and managing one or more clusters moving forward. So the first one I'm going to talk about is the self-service usage mode. So this is a Kubernetes cluster that's going to be acting back on to itself. So this was the original design when we originally started talking about the project, was this idea of Kubernetes managing itself. The problem here, though, is if you've read my book, The Cloud Native Infrastructure, you know that we've defined this really hard problem to solve called the bootstrap problem. We saw this in writing C compilers for the first time when the compilers had to compile themselves. We now have the same problem in Kubernetes. How do you create a Kubernetes cluster from thin air that's going to ultimately manage itself? So coming up with clever ways to solve that is what the SIG has been working on over the past couple of months. Furthermore, there's a problem because there's a source of truth concern here. If you define what the cluster should look like in the cluster itself and something goes wrong with the cluster, who knows what the cluster is supposed to look like? So there's a bit of a concern there. We solved this in kops by putting the definition of our cluster in a completely independent system. We store it in S3, and that's how we separated our concerns along the way.
Okay, so the second usage model is the management cluster. I think everybody here who has worked in enterprise understands this concept. So this is a separation of concerns. We divide up the roles into the cluster administrator and then the cluster creator. And for this, we need to first deploy a secondary management cluster. And we're going to talk about that a little bit more when we talk about the vSphere provider. It is a little bit more complex, but it also provides a lot of flexibility that we're going to talk about. By the way, these terms that we're using, these are terms that we just started, we've been using organically in the meeting. So, I mean, there might be better terms.
They're as official as they can be.
Yeah.
Cool, so let's go into self-service a little bit more and learn about some strengths and weaknesses to this approach and talk a little bit more about the broader design here. So this is when Kubernetes manages itself. It can either manage itself via the bootstrap problem or by a bootstrap cluster. So a bootstrap cluster is a temporary ephemeral cluster that is used to create other Kubernetes clusters. I use the word ephemeral there specifically because this is not designed to be a cluster that lasts very long. It just serves as sort of our springboard into building other clusters later. And we can see a concrete example of this when we look at the AWS provider, which we're going to talk about in a minute. So some traits of a self-service cluster that is built using the Cluster API is it has to solve the original cluster problem. So at some point, we have to say we need some cluster created somehow, whether that's using a tool like Kubernetes and Docker or Minikube or maybe a managed service somewhere. We do need an initial cluster to start the process on. And in this case, we use Minikube by default. Furthermore, it's centralized storage of cluster declaration. This is what I talked about earlier, where the actual representation of the cluster itself is stored inside of the cluster. So one of the great strengths of this is it's extremely simple. You can understand it pretty easily. I have some CRDs. They represent a cluster. I have a controller that manages creating and mutating that cluster over time moving forward. So one of the big weaknesses is its decentralized nature makes central accounting of the clusters harder, and it may not be allowed in some enterprises. So as we started talking to more corporate implementations of the Cluster API, we actually learned that defining secrets is fairly important, and how we're going to start managing those is going to be a concern we need to start looking at a little more in depth. OK, so here's a lovely diagram of a self-service cluster. So let's start at the top, the cluster CTL or cluster Cuddle command line tool. This is the same command line tool you would use regardless of what cloud you're running in. And you would use cluster Cuddle to first create a bootstrap cluster. So in this example, we see that you could use Fusion or VirtualBox, and this would actually be what is running Minikube. And this would be running locally. If I was running this in my MacBook here, I would run a cluster Cuddle create command. It would then spin up a Minikube virtual machine, and that would serve as our bootstrap cluster. Once that cluster is up and running, we would define the CRDs, we would install some controllers, and those controllers would then, and now we're moving across the bottom of the screen, would actually go and bring up the target cluster. And that cluster is what we would actually plan on keeping online, and what we would ultimately do a shift of the declaration of the cluster from the initial bootstrap cluster into this new cluster, where we have everything defined, and the controllers can then begin to reconcile themselves. So in this example, this is a little more vague, but we wanted to speak to the power of the Cluster API. The community and the broader SIG has come together and written tools and common libraries to make this easier for you, an implementer, to go and write. But the shape of the API surface itself is where the real value is here. So in this intentionally ambiguous diagram, we wanted to point out that you don't necessarily have to use Cluster Cuddle. You don't necessarily have to use the tools and the libraries that the Kubernetes community is working on. But the API shape still remains the same. And speaking that API shape is going to be important as we start looking at standardizing what a Kubernetes cluster looks like moving forward. So in this example, we could have one or more ambiguous tools that would handle creating a cluster, defining some CRDs, and then reconciling those CRDs and managing one or more clusters moving forward. This would still fall under the self-service model, just implemented a little more loosely. OK. So now when we talk about the management cluster, this is the new pattern that the working group has started investigating. And it solves the bootstrap problem by first installing an initial cluster. And the traits are that it has two primary roles, the administrator who installs the initial cluster, and then the cluster creator who creates a cluster for maybe their department or something, or a business unit. And it also has a central storage for all the cluster declaration. Now, the strength of this is that it centralizes the accounting of cluster resources used by the clusters. And users don't need extra software like Fusion or Minikube. The weakness is, of course, that right now, while this is still immature, it may be a little bit harder to debug or get logs. Okay? So this is a diagram, and you'll see that it's a little bit similar to the self-service model, but it's a lot simpler.
It's a lot simpler in that there's less boxes. But so you first have a management cluster that you deploy somehow. And in this diagram, notice that there's two types of target clusters here. And this is important. So the one on the left has a target cluster that's very similar to the self-service cluster in that we can deploy the cluster API onto it. Why do we want to do that? Because we want that cluster to be self-managed, to be, if you want to modify the cluster, you can tell it to modify and it will reconcile itself. And then the target cluster on the right is a skinnier cluster where it doesn't have the cluster API, but you can't do self-edits on the cluster. And we're not sure which way we're going to go yet with this. Maybe we'll support both.
Well, it's up to each specific cloud provider, right? Yeah.
OK, so let's talk about the vSphere provider. So the vSphere provider supports both the self-service and the management cluster model. The admin workflow is this. So any of you guys who are are familiar with vSphere knows about OVAs. And it's a very common deployment model. You first deploy an OVA, and the OVA creates the management cluster. Then the administrator pulls the kubeconfig from that cluster and then deploys the cluster API to that cluster, then creates a VM template, and then uses that, then provides the kubeconfig to the cluster creator. And the cluster creator can just use the kubeconfig for that management cluster to then create target clusters. So why a management cluster? This is a model that I think a lot of our customers are administrators and DevOps, and this is a model that's very familiar to them. They want to be able to see all the resources being used on vSphere, and this provides that for them. And also the OVA is a very common deployment model. So this is something that they're very familiar with. And in addition to that, one of the benefits of an OVA is that during the deployment installation, we can actually customize the management cluster itself with UI wizards.
All right, so let's talk about the AWS provider. I've been trying to set up Kubernetes in Amazon, I think probably 2.5 years now. The first good tool I ever used was Kops. I then developed my own opinions and wrote KubeCon. That turned into an open source project. I then watched EKS come to life and have since been a part of demoing and talking with some of the creators behind EKS Cuddle. And then ultimately, all of this knowledge with myself and a lot of other really, really bright folks in the industry came together into what I call the therapy doc. And this was just a document that we put together in the Kubernetes open source communities under SIG cluster lifecycle that captured all of the lessons learned, the frustration, and the weird API behavior that we detected as we began to look at not only creating the cluster in Amazon, but actually running that cluster over time, scaling that cluster up and down, and upgrading that cluster as well. So SIG AWS, one of the Kubernetes SIGs I'm a co-chair of, and SIG Cluster Lifecycle joined forces to create the AWS Cluster API Provider implementation. And this is a very fancy way of saying we took the cluster Cuddle tool and the cluster API shape, and we wrote an Amazon-specific implementation that you can actually go and run today. I did a demo on this a few weeks ago, and I'll be doing another demo on it later today if folks want to see it. And we might be able to look at something at the end of the talk here if we have enough time. But ultimately, this uses a bootstrap cluster. It uses Minikube today, and it goes in and defines, I think we're using CRDs now. We were using an aggregated API server before, but I think we finally switched over to CRDs again, which is a long history there, to define a cluster in Amazon. And here we would define things like VPC information, security group information, the type of EC2 instances we want to use, the version of Kubernetes we want to use, et cetera. We get a lot of the resiliency concerns that you see in the rest of Kubernetes, and this would actually go and create a Kubernetes cluster in Amazon, and then we would be able to take those same Kubernetes cluster definitions and change them, and the reconciler would reconcile them over time. So on the right side of the page here, we can sort of see a little bit of the flow. We would first create a bootstrap cluster in Minikube. It would handle all this TLS secret generation it needs to. It would then go and create a second cluster in Amazon against the Amazon API, as long as you had an Amazon IAM set up beforehand that allowed you to create all the resources needed. And then there would be a controller manager that wraps up a number of different controllers that then would go and actually handle creating every specific piece of infrastructure behind the scenes to bring an Amazon cluster to life. And that's how the AWS provider works. So right now we're using a very simple self-service usage mode, but ultimately we want to explore other ideas as well. Also important to note that the intermediary bootstrap cluster along the way is an ephemeral cluster, and the cluster will manage itself moving forward.
Yeah, and I think we talked about this earlier in the presentation that eventually we want all of the providers to be able to work together. So I could see one day for vSphere users, we can ship an OVA that has all the providers. So you can deploy to vSphere, you can deploy to AWS, you can deploy to Google Cloud, and that's the hope. Okay. Cool.
So at this point, we're going to do open Q&A. A lot of folks have come up to me at the conference. I think some folks have come up to you as well. If anybody has any questions, we can answer them now. I noticed we have some folks from the SIG here as well. And we're happy to answer any questions along the way or clarify anything if anybody has anything. Yes?
I'll shout out.
I'll say it back too.
Is there any work here to, it sounds like there would be work to integrate this with something like cluster registry so that if you create a cluster, then you're able to do like federation feature type stuff with that plan or anything?
So let me repeat the question. So the question was, there's a concept of a thing called a cluster registry, which is sort of like a kube configs as a service. The question is whether or not this project plans to integrate with this other effort in the community along the way.
So there is an issue open for that, but no one has looked into it yet. But because we've been pushing, we're one of the companies that have been pushing the management cluster, I think we're going to start looking at that next year.
I think just overall the sentiment was, yes, most folks thinks it's a good idea to start working there. I think it's just a matter of figuring out how that's going to fit together. Question?
As a user of COPS, I really love the terraform output as an option. Is that something that is still being kind of prioritized within the cluster API, actually?
As a COPS user, what's your name? Darren really enjoys the Terraform target output, which allows you to create Terraform config from a COPS definition. The question is whether or not Terraform is going to be supported in the cluster API. I can take it. You got it?
OK, go ahead. OK,
cool. Pull requests accepted. So yeah, I think right now we have a number of different providers that are out there, but it would be relatively trivial. Well, not trivial, but I mean, it would be pretty easy to at least start off working on the project with the tools that we have in place.
So I just want to also add that not all providers are using Terraform. The vSphere provider originally used Terraform, but debugging Terraform, you're introducing another stack that has another sets of operation and rules. And so we traded that out for vSphere API. So I think some of the other providers are also using their own native APIs.
And if you look at the history of the project, before we moved to the new repository, there was a Terraform provider once upon a time. So there might be some work there that we could look at as well. How much time do we have left? We have 7 minutes, so we'll try to keep them quick. Let's start here. I think I saw your hand up first. This is the best question. OK, so can you use this to stand up a cluster on bare metal? So I think there's two answers there, and that depends on how you define bare metal. So the first one is true bare metal, which is like a machine that you plug into the wall with an RJ45 running an operating system. And then there's VMware, which is the vSphere provider. So the original goal of the project was to be inclusive to bare metal. Now that I work for VMware, have a deep interest in this, so stay tuned for more information. We also have an SSH provider that allows you to configure over an SSH connection that you could use to stand up bare metal as well. So we're working in that direction. Front row, and then we'll get you in the back.
I have a quick clarifying question. Amazon provider?
Sure.
EKS clusters or just clusters in EC2?
OK, so the question was, does the Amazon provider create EKS clusters or clusters in EC2? So it creates a non-EKS compliant cluster, although we have, as a community, shared a lot of similar ideas.
And a follow-up. And any of the providers, how far does it go? It creates the cluster. Does it create any high availability aspects to the cluster or monitoring or anything like that?
So the question was, how far does it go? Can we do HA? Does it do monitoring? What's the scope, effectively, of the Cluster API? The Cluster API manages cluster infrastructure only, bringing up the layer of software that we humans call Kubernetes, and managing that over time, and it stops there. 1, 2, 3, and then I think we'll be out of time.
So have you considered integration with open service broker?
Have we considered integration with the open service broker? I have not, off the top of my head, I haven't heard anything about that, no.
No, me neither.
Question? Can somebody help me? I can't hear.
How do you deal with dependencies like Docker and etcd, especially when you're doing upgrades?
OK, so the question is, how do we deal with dependencies like Docker and etcd when we're managing upgrading a cluster? As we mentioned, we're still in experimentation mode. We're still developing a lot of these strategies. We actually talked at the Contributor Summit about the upgrade strategy for the project and what we want to do there. So we're still figuring that out. Question, let's do the back, and then you here in the front.
Has there been any consideration for running the Kubernetes control plane inside the management cluster, specifically as it's going through Cluster API?
Have we considered running the Kubernetes control plane inside the management cluster, like a cluster on a cluster? Is that what you're asking?
So your API server is a deployment within your management cluster rather than a VM that you stack out.
Go ahead.
So in a management cluster, we are still running a Kubernetes cluster in there. I mean, at least we're running a master.
Yeah, so you run the API server for your target cluster in the management cluster, so you don't have to.
I see. So the question here is effectively, are we doing, I forget there's a name for it, but it's where you would run the Kubernetes control plane as a deployment or set of deployments on the management cluster. So this is where you get into like a hybrid model of like how do you bridge the gap between this new cluster that is just nodes only and you're running a control plane on another Kubernetes cluster. There's a bilateral communication there, so however we could solve that. I mean, we've thought about it. I think it's possible. I haven't really heard of anybody actively working on it, though.
Yeah, and right now I think the working group is mostly focused right now on the target cluster being able to manage itself, so that if you create a machine set and one of the nodes go down, it can create another node.
Sure.
So.
Yeah, basically it was my question, like why is it only one entity and not like control plane?
Sure. I think that's a possibility. I think that's one of the big reasons why we wanted to start defining this as a CRD and using operators in the first place, is so that we could start making this much more portable. Anyway, the question was, why don't we have any examples like this already? And I just think we're not there yet.
Yeah.
Any other questions?
Okay. The next topic is that there is going to be another session later this week on Thursday. It's going to be a deep dive on Cluster API for those who want to maybe contribute to the project. And then the last part is that we created a survey. You saw the self-service in the management cluster model, and we want to hear your opinions. And we have a bunch of questions, and we'd like to hear your opinions on a lot of this, because we're experimenting right now, and we would love to know if we're going in the right direction.
Absolutely. At the end of the survey, there's also an optional spot where you can write your email address if you would like for us to follow up, and we can have any other discussions moving forward. So if you want to talk more with folks at Heptio or folks at VMware, feel free to hit that survey, and we will go from there.
Okay, I just wanted to say one last thing.
Sure.
I'm sorry we didn't have time for a demo today. The demo would have taken a lot of time. But later next week, we're going to have videos of the demo of the vSphere provider with the management cluster and the OVA deployment up on our repo. So next week after KubeCon, just
Right.
look for that.
Thanks for coming, everyone.